Welcome to all. In this course, GSM RF optimization and drive test. And this one is the first module in which we will discuss the GSM RF channels. Actually, these channels we can use or frequently in our this course. So first we will discuss the GSM RF channels. In this GSM network, first what BSNL is using, that is the GSM 900 megahertz band and DCS 1800 band. This GSM 2 bands that is BSNL is using. The uplink and downlink, GSM actually supports FDD transmission mode, in which the uplink and downlinks are transmitted on different frequencies, right? And just like when BTS transmitted towards the user equipment, that is the downlink. When your mobile transmit towards the base station, that is the uplink. So there are different frequency for uplink and downlink in both the band, GSM 900 and DCS 1800. So what is the third point is the duplex distance. Duplex distance is 45 megahertz in GSM 900 and 95 megahertz in the DCS 1800 megahertz. That means duplex distance means the difference between uplink frequency and downlink frequency. When we subtract 935 megahertz minus 890 megahertz, the starting frequency of uplink and downlink, it will come 45 megahertz. Right? And one carrier separation means the bandwidth of a one carrier is 200 kilohertz in both case of different band, GSM 900 band and DCS 1800 band. And total number of available carrier, or we can say channels, is equal to 124 in case of 900 band, and in DCS 1800 it is a 374. And it indexing from 1 to 124 in case of GSM 900, and it carrier index from 512 to 885 in case of DCS 1800 band. And SS method used is TDMA plus FDMA. In GSM network, in all the bands, the SS method used is TDMA plus FDMA. In this overview of GSM channels, that is the downlink and uplink channels, where downlink is from base station to the mobile station, and in the uplink from transmission from mobile station to the base station, right? And what is the physical channels on each carrier? On each carrier, the time slot, they are divided into 8 time slot. That is referred as a physical channels. Per carrier, there are 8 physical channels. And logical channels. Logical means different traffic channels and control channels that is mapped on these physical channels. We will discuss what are the different control channels that is used in the GSM network. The traffic channels, that is the two types, that is the traffic channel full rate and traffic channel half rate. After that, we will discuss the control channel, in which we can see 3 types of control channels are there. First one is the broadcast channel, that is downlink only. Second one is the common control channel, that is it can be both uplink as well as downlink. And third one is the dedicated control channels, right? That is both way uplink and downlink. So within a broadcast channel, within the classification of broadcast channel, there are 3 types of control channel: BCCH, synchronization channel, and frequency correction channel. These three channels are there. Total actually 9 channels are there. 9 control channels are there. Right? In common control, that is the RACH, paging channel, SS grant channel, and CBCH. RACH is used for uplink synchronization, that is used only for the uplink. Cell broadcast channel is the for downlink for broadcast information. And paging channel and AGCH is also used in the downlink. Next one is the dedicated control channels, in which SGCCH, that is the standalone dedicated control channel, that is used very much in the signaling in the GSM network. And some two associated control channels are there, that is the fast associated control channel. Second one is the slow associated control channel. And these two logical control channels basically used for the measurement period. SSCH is used for the measurement reporting, right? And FSCH is used for sending the handover commands where the fast scheduling were required. That channel FSCH is used there. So these are the basically 9 control channels. BCCH, synchronization channels, frequency correction channels, random access channel, paging channel, SS grant channel, right? HGCCH, FSCH, and SSCH. We will discuss this logical channels in our GSM network optimization course. This one is the just a description of overview of the channels, physical channels, right? Time slots, the uplink and downlink frequency band in 900 megahertz band. You can see here in the uplink, it is a total 25 megahertz from 890 to 1950. And in the downlink 935 to 960. And duplex distance, you can see here the difference between the uplink and downlink, that is the 45 megahertz. And total number of carrier is ranging from 1 to 124, and it is known as the ARF chain, that is the absolute radio frequency channel number. And one carrier is divided into 8 time slot, that is the one time slot duration is the 0.577 millisecond, and total combining 8 time slot, it becomes a frame, that is the 4.615 millisecond. Right, this one is the different time slot duration and frame duration that is frequently used in our GSM network during the communication. And some of the channel multi-frame, actually these are the structures, fixed structure we are using for traffic as well as control. So this first one is the traffic structure, burst structure, we can say use fixed pattern that is used in the GSM network. So for traffic channel, this one is the 26 frame multi-frame, right? In each frame from 0 to 11th, we are using the traffic burst, and 12th is used as the slow associated control channels. And last one, that is the 25th, we are using as a idle, right? That means T for traffic channel bus, S for SACH bus, I for idle. The fetch is actually not allocated slots in this multi-frame. Why it not used? Because it steals traffic channel slots when required. When handover command is there, right? Indicated by the stealing flag in the normal burst. If you see the burst structure, there is a stealing flag is there. That flag indicate that this is a time slot burst or it is a fetch burst. Control channel multi-frame, this is also a fixed pattern that is the 51 frame multi-frame, right? 51 frame multi-frame. So where we start from frequency correction channel, then synchronization channel, then 4 bursts of broadcast control channel, then 4 bursts of common control channels, right? then again this pattern is repeating, and then burst last burst is the idle. So this one is the fixed pattern that is transmitting on the control channel, that is for the broadcast channel, BCH channel, right? This is for downlink, and again there's a uplink for RACH is there. The different control channel format of 51 frame multi-frame in uplink and downlink. Thank you for listening.